Hey, want to quickly talk you through how to use Vernier video analysis to let you grab a piece of video and get some data out of it. So I'm going to import some video and I'm going to choose a file, and I happen to have something ready here. It's this yellow car recording, and we'll bring it up, and let's just have a look at what this looks like. If I play it, oh, we see a yellow car run down a ramp. So I want to get data. I want to know where the car is at each moment, and I want that in physics form, not just where it is on the screen. So I'm going to, just to be able to do this well, I'm going to close up this graph and table. So I'm going to go graph, close that, data table, close that. That's what this little who's this right here. So now, oops, I don't want that to happen. So what I'm going to do, go away. All right, what I'm going to do is I've made it big, I'm zoomed in, and I want to essentially identify where this car is along this ramp in every frame. And the way we do that is I click on the add point, and I'm just going to click on the car. Now, it would be really good if I clicked on the same part of the car every time. So I'm going to click on the front wheel. Click, click, click. Oh, the person hasn't let go. Oh, now they're starting to let go. Oh, it's moved a little bit. Oh, and I'm just clicking in the same place. Every time I click, it automatically advances by one frame. Click, click. Now, I'm not going to pretend that this isn't tedious, but it really is not going to take me very long. There is an auto track feature in this software. And for some situations, it works really nicely. And for other situations, it does not work really nicely. A moment ago, I tried it on this yellow car. Not very good results. So you can try the auto track feature if you want, but for the moment, you're going to be on your own on how to do that. I think it's a little weird. I'm noticing these strange gaps as I'm clicking this thing, and I'm thinking, is there something odd about this video file, or is there something odd about how the car actually was moving that day? But I don't know. So I'm just clicking away here. It does sort of feel like there must be gaps in this video, but I don't know. So click. I had zoomed. I should zoom in again on a different part. Click. I'm clicking on the wheel. I'm just going to say I'm done for the moment. So what's important is we've told the software where the car is in each one of those frames. So I'm going to zoom back out here. The next thing we need to do is to tell the software what the scale is. So I'm going to go over here to System, and that basically means the physical system. And I'm going to grab this end of this bar. I'm going to put it at the end of this meter stick. Notice there's a meter stick here. It's actually a 2-meter stick. I'm going to zoom back out, grab this thing. I'm going to find the 1-meter mark. Now, there always has to be something in your video that you know the size of, and that thing that's the size of needs to be the same, in the same plane as your object, right? If I was like, I know the size of that tree, that's not going to help me very much, right? Because the size of that tree, it looks small because it's way in the back. So once I've done this, Logger Pro now is like, oh, 846 pixels is 1 meter, so it's going to use that. The other thing I'm going to do is I'm going to decide where is the origin. So I'm going to click over here on origin, and I'm going to say, where do I want the origin to be? Now, you can always pick 0 to be anything you want, right? I could put the origin down here and have my car moving toward the origin. But, we're kind of conditioned to like positiveness. So what I'm going to do is I'm going to scroll my car all the way back to where it started. I don't have to do this exactly, but I'm going to put the origin back where the car started. So I'm going to bring this up here, zoom in, and I'm just going to put that origin right where the car started. I'm going to zoom back out. Now, notice that if I run this, the car is going to be changing in X and changing in Y, and it's going to be moving negative in X. So I'm going to do this trick where I'm going to grab the X-axis here with the little arrows. I'm going to grab the X-axis. I'm going to spin it around so the X-axis goes right along where the car is going to be going. In fact, not just the X-axis, but the positive X-axis. So now my car is just going to be moving in a positive X direction, which is really friendly. I mean, we always like things that move in the positive X direction. So now if I go back here and pop open my tables, and I'm like, boom, here's a data table. So now we've recorded the position of the car at all these different times. And now I can click on the graphs and I can be like, oh, so now I see the graphs. All right, I'm going to make this graph big because honestly, right now I don't care that much about the table. Let's close the table. I'm going to make this graph really big. So here's my position graph for my object. And I don't really notice the y hasn't changed. Why? Because it's running along that, the y coordinate didn't change at all, just the x coordinate. What I want to know is, how did this thing accelerate? So I'm going to go over here and I'm going to change, it says change y-axis, and I'm going to change this and say, I don't want these positions. What I want to know is, what's the x velocity? And lo and behold, I get a graph of the x velocity. It's a little clunky. I kind of suspect is something going on with this video file, but I'm going to live with it. I'm going to, at the beginning, notice the velocity is 0. That's because it hadn't started yet. I'm going to select, I think I can select. Can I select a bunch? Yeah. I'm going to select a bunch of this data. I've selected a whole bunch of this data. And then I'm going to say, give me a curve fit. I'm going to say apply a curve fit. And I kind of like the idea of calling this linear. So I'm going to apply a linear curve fit. And here we go. Here is a linear curve fit for all that data. And notice it gives me a slope. And the slope of the velocity graph is the acceleration. So while we might investigate the underlying data here because there's this weird bouncy thing, I'm going to say that the acceleration of that car was about 3 meters per second squared. And that is how you use video analysis to find an acceleration. One other quick thing. If you're measuring something that is falling and you're like, oh, it's falling straight down, you don't know for sure whether your camera was held exactly vertically. So it is a really good idea to align one of your axes with the path of your object so that your object stays all in the X or all in the Y. It's just going to make your life a lot easier. Okie doke, try that.